Example problem 4 asks us to calculate the speed of sound in air. Then it gives us a density, and it gives us a new variable called acoustic impedance. That's what Z is. And so the formula that we're going to use for this is this one right here. This Z equals D times C. So Z equals D times C of sound. So it's asking us to calculate the speed of sound in air. So C of S in air. It gives us a density for air. So the density is going to be 1.204 kilograms meters minus 3. And the acoustic impedance, that's what that Z means, for air equals 413 kilograms meters minus 2 seconds minus 1. And of course we know that speed of sound is measured in units of meters per second, and that's what we're going to calculate. So our Z is 413 kilograms meters minus 2 seconds minus 1 equals the density, which is 1.204 kilograms meters minus 3 times X, because that's what we're looking for, is this variable, the speed of sound right here. So we're going to divide by 1.204 kilograms meters minus 3 to isolate the speed of sound by itself. And so what you do to one side, you have to do to the other. So divide it by 1.204 kilograms meters minus 3. So in your calculators, it's a pretty simple mathematical equation. So 413 divided by 1.204. And so getting out of scientific notation here, because this is a small number, 343, so C of S in air, equals 343.02 meters per second. Let me know if you have any questions about example problem 4.